Okay, so in this video we will be working on the draft analysis check. I'll go to analysis, we'll go to draft, then we have this icon over here. Now I'll just go to what do you call direction pad, and I'll select the part, basically the complete part. Then I'll just go to direction and I'll go to the top, and automatically we'll be having some colorful values over here. Okay, and if you want, you can just enter a value which we want to check with. So for example, if I want to see are there drafts with respect to 1 degrees, I'll press enter. Now you can see there are white color walls that indicates that is 0 draft. Okay, and the flat surfaces we need not be bothered, because the flat surfaces, as the direction is in upward direction, the direction of pull, so the flat surfaces are not that much bothered about. The vertical surfaces has to be looked at. All right, and let us look at the inner side, because we have already added the draft. Now you can see all of them are in same color. Okay, that means a negative draft is present over here, which is what desired for us, because when you're pulling the part, it has to be in this direction. Okay, or the drafts has to be in this form. So this is pretty clean walls inside. We don't have any white color wall that indicates no draft, and we don't have any undercuts that indicates positive draft. I'll show you an example of positive draft, okay, or undercut. So I'll edit this draft, I'll change the direction, I'll just press OK, and I'll just come back to draft. I'll click on direction pad. That means I'm selecting the complete part. I'll go to the direction and select the top, because we are pulling it in the top direction. Now you can see that all the surfaces which are appropriately drafted are in this color, a kind of reddish color, or whatever you define for this color, a reddish pinkish color. But this surface is blue color. This indicates there is a mismatch. You cannot have a part which with a draft in opposite direction in between the parts which are having draft in one direction. Okay, so this is an undercut. These kind of part cannot be created. Now I'll just go to the section view and show you again. First, let us turn on the draft analysis again. Select the geometry, click on direction, top. So now you can see that if I am, can I save this? How do I save analysis? I'm not sure, I forgot. Saved. Okay, yeah, it has saved. I don't know why they wrote saved over there. They should write save, right? Anyway, we cannot complain Creo Parametric company. So you can see that this is well and good. Conventional method of explaining. So when it is being pulled in upward direction, okay, the part will be lifted upward. Imagine the part is being lifted upward. Okay, we have this core being created in this way. Okay, now you can see it is parallel to this wall, so it is perfectly drafted. This region can be coming out, but this is a negative draft. Okay, that means it is having a draft in opposite direction. So this indicates that this draft cannot be pulled outward. Okay, because you can see that the material after filling will fill up in this. I'll just explain very neatly. One second, I'm sorry for this, because a rough diagram will confuse the user further. I'll just copy this. I'll make a very neat presentation very quickly for you. Let me paste it over here. Okay, so imagine our box or the core to be in this shape. I'll just use the shapes over here, okay, with the help of line. So whatever shape of the walls we have, that shape will be followed for the core. Okay, tool and die, when they are designed, they're designed with respect to the shape what we have. Okay, what we have given to the manufacturer. I'll make them something unique color. Black is fine. Copy and paste. Imagine your core is in this manner. Okay, and copy and paste. All right, so this is the undercut, this is a positive draft. Now when you're pulling it upward, okay, you can see that when the part is being pulled upward, just focus on the left side. Okay, I'll just push the part upward. You can see that it is easily pulled out. Okay, it is easily, the core and the part will not be scratching each other. They will be having a rather clean movement. Okay, a slight clearance will be there, but in this drawing it's not visible, but technically it will be slightly visible when the part is being drafted. You can see here there is some clearance over here, and automatically the part will be moved smoothly upward if there is a similar draft on both the sides. Okay, but in this part what's happening is, so this is the way of arrangement. Okay, the part is cooled down. Now we have to remove it. When we are removing the part, you can see that the core over here, that will be touching the material. Okay, so this is the material, the grayish material what we have. Okay, when we are moving it upward, it is touching the material. You can see it is moving inside the material. Can you see it? That means it is scratching intensely, right? You can completely see that it is moving into the material, and that is not correct. The core should not be touching the material. And you can see on the other side, because of draft, we have good clearance over here, isn't it? So this is the way undercuts are not correct actually. Even if you are making a core with undercuts, after cooling down, when you're pulling out, you cannot pull it out because the material is jamming off. Okay, technically they both are inclined in a way that it cannot be pulled out. You can see if because this is an animation, we are just pulling it out, but when you can but you can see that it is moving inside the core boundaries inside this gray material. That means it is hitting completely, whereas on the drafted side it is clear and open, right? So this is the reason why we have this drafts being added. Now how about the upper side? Okay, we should be adding drafts over here as well. Okay, so we will be doing that thing right now. We will be going to this draft analysis. First thing is we will be editing this draft, changing its direction. Okay, now we will come back to this and we will take a snip of this one. I want to show you very clearly, there shouldn't be any confusion. I'll paste it over here, send to back. All right, let me just adjust appropriately. This is drafted. Parallel to the draft. Okay, I cannot move that further. Now you can see when this image or this part is being pulled up, the core is not touching the shaded region. Okay, it is not inside it, whereas in the previous case it was completely inside it, right? So this is the reason why we have this drafts being added to the walls. All right, now I'll just come back to the Creo Parametric and we'll turn off the sectional view. And how do we get rid of this saved analysis? Turn it off. And what do? I'll close it. Fine. So we are trying to learn other options in Creo Parametric apart from working on this detailed course. All right, now I'll be adding draft for this one. Draft hinge, I'll be selecting this base and I'll be adding 1 degree draft. Okay, inside. Now I'll be selecting surface, adding to all the surfaces with the help of control key. All the vertical surfaces must be drafted. The vertical surfaces are the surfaces which are parallel to the pull direction. This is the direction, so these are parallel to it, and also these tiny surfaces what we have. Now we have to work on the draft for the joystick covers as well, which we will be doing along as we move forward. We have to add the rounds. Drafts are the most important thing. Oh my goodness, sometimes we miss pressing the control key. I selected internal surfaces, yes. Now the value of draft depends on different parts. Sometimes, you know, depending on the complexity of core cavity, the tool designer will ask us to increase the draft to 5 degrees or 3 degrees. Okay, but a minimal draft should be present at the moment. I'll just press OK and Control D. Alright, now let us just go back to analysis, draft, select the part, direction is upward. Now you can see we have completely in a single color on the top. Okay, so this is a positive draft. Here we will be having the negative draft. There shouldn't be any white color being present. There is a white color over here. That means this is a non-drafted surface. So I'll select one of the drafted surface and I'll go to the surfaces, select this one. I'm sorry, what's happening? Let me turn this off. I'll press OK. So I have added the draft for this surface which was missed. Let us again verify the analysis of draft. And there are no white color surfaces. All right, and apart from that, there is one other information. The line at which the red color and the blue color meet, that line is called as the parting line. Okay, again you can see that this surface is missed. I'll be adding the draft to that as well, don't worry about it. But overall we have completed the draft analysis for this. Now we can just hop to add the rounds for the surfaces. Okay, let us come back with this rounds. I hope these will not fail. Yeah, these are not failing, so we have added enough rounds. I think we can stop the video at this position, and with this video we can say that we have completed the modeling of the direction pad, okay, which is used as one of the, what do you call, one of the component in the joystick. All right, so let us just move to the next video, and after pausing the video I'll be adding the fillets or rounds for all the edges. You can also do the same thing. Try to see that you don't maintain any what do you call, any sharp edge, because sharp edges are not desired. Okay, all the edges should be having minimum amount of rounds. All right, so that is what I'll be doing after this video, and see you in the next video.